Hello everyone, welcome to this video where we're going to be looking at how we can use S-FRAME to perform code checking and design operations on our structure according to the Korean KDS 1431 code. So I have this model. This was actually generously provided to us by our client Skidmore, Owings & Merrill. It has been modified after the fact, but this represents an airplane hangar, and we've already applied loads and boundary conditions and cross sections. As you can see, we have a few different cross sections on the model. And we're going to run an analysis on this structure and then perform a code check and a design. Now in this example here, I've got it already set up to use the Korean design code. So I'm going to go to the settings menu and preferences. And in this window that appears, I can go to the design code tab, and you can see here the steel database that's being used to grab sections from, and the steel design code that we're going to be using for the code checking operations. So I'm going to click OK. Now, for the sake of brevity, in this particular example, I've already ran the analysis ahead of time, so I'm just going to jump right into the graphical results window. And here we can see that we've got a couple different load combinations that we've analyzed, and obviously the load cases underneath that as well. And we could look at things like our deflections, our forces in our elements, and so on. But I'm actually going to jump right into the steel design, so I'm going to click on the Run menu and go to S-Steel. And within S-Steel, I'm going to use this environment to code check and design a portion of my structure. You may notice here that I have a variety of different members that have been selected, and there's a few that haven't. That was done by design, so if I just left click on one of these unselected members here, you can see they're showing up as basically dashed black and white lines. I get this member indicating here that the member cannot be code checked because in this case the section is not found in the steel section database, or the section is not supported by S-Steel. This could also occur due to a material that doesn't represent steel material. There's different reasons for why this might occur, and by double clicking on one of these unselectable elements, we can see why that might be. I'm going to focus in on the structure that is selected, however, and I'm going to start by performing a code check. So a code check is basically an operation that looks at the demands that came through the structural analysis on all of our members for all the different load combinations or cases that we could choose to code check, and compares them to the design code capacity for each of those sections based off of whatever design code that we've selected. In this case here, the Korean design code. So I'm going to go to the Run menu to do this and click on Code Check. And we're brought into this window that allows us to select which load cases or combinations we'd like to pursue the code check for. In this situation, I'm going to select just my load combinations. Now we could have both SLS and ULS load combinations. I just have the ULS load combinations for this example. But we could use the SLS load combinations to look at things like deflection limits, for example, or looking at camber in our composite beams and so on. I'm going to click on the OK button to run the code check. And after the code check is completed, we're brought to the code results window. And what we're seeing right now is basically a set of utilization ratios for every member that we've code checked. This is actually using a different view than I had previously shown you, so let me switch to that other view. And we can see here a range of colors, and this code utilization legend is going to be helpful for us because it's indicating to us which members are exceeding the design code capacity and which ones are perhaps over-designed or just passing the code checks. So anywhere we see red is generally a concern, and we can zoom in on some of these areas. Let me just drag my aerial window over, and I can use the zoom window option and just pick a few spots that I might want to drill down into a little bit closer. So I can see here this range of utilization ratios in this roof members. I'm going to look at this utilization ratio of 1. I'm going to right click on it and I'm going to click on code details. And this opens up a report here that's showing me the S-frame section that's being utilized, a little graphic of that S-frame section, and then for every load combination that we've checked against, it's showing us whether that member is under bending, tension, torsion, or some other combination of loads. It's going to also perform a variety of different checks and identify which one is the governing check for that particular load combination. And for each case or each design check that it's performing, it's also showing us the clause reference that we can then refer back to our design code for if we want to. So for this load combination number 1, it happens to be governed by flexure and tension interaction check, but the utilization ratio is only 0.614, so it's using 61.4% of that particular demand or capacity of that member. Looking further down here, we can see load combination 2 is highlighted as a governing member. And what we notice here is for that same check, low combination number 2 has a higher utilization ratio of 1.019. So it's actually just exceeding the capacity and would obviously need to be considered for a redesign. We can see here that we have this shown in red text. So it's not trying to hide any of that information, and it's showing us some of the values that went into that as well. Now this is just for one particular member that we've chosen somewhat at random. But if I just zoom back out here, we obviously wanted to study the whole behavior of our model as well. So I can go to the File menu, and I can say, let's go to Print Key Results. And if I go to Print Key Results, we have the option to toggle on or off different objects that might be of interest to us. And I'm going to click OK, and it's going to produce a report for us. And this is just on the other screen. I've dragged it over here. And you can see we have different design groups in our members selection set. So it allows us to group different cross sections together to design them in a more efficient fashion that's probably more lined up with the realities of the construction sequence. You don't want to have every member have a different cross section. And this is showing me the section group name for each of these members and the steel cross section assigned for that, and which member might, or which low combination might be governing. So in most of these scenarios it's low combination 3, but there is one where it's actually governed by low combination 2. And the utilization ratio. So some of them are quite highly utilized and would obviously need to be reconsidered. And I can scroll down through this report, and this is showing me where those highest utilizations are occurring. So I can see for my particular, this is a tie section. You can see here the cross section is experiencing quite a high utilization ratio for biaxial flexure and tension interaction check. But if I scroll through this list, I can see other members that are experiencing similar issues. Maybe not all of them are failing, but we would obviously want to consider revising some of these. And there's a list of all the performance of all the sections, and at the very bottom, I can see a summary of quantities for the selected members. This is showing me basically the cross sections that we've considered, the length of each one of those members summed up, as well as the weight that's being used. So obviously if we want to minimize the amount of weight in our structure, we want to make sure that this is as low as possible. Some cross-sectional databases will also include surface area, which we can then optimize for. As well, we can enter cost data to optimize for whatever might have the lowest cost. Let's just use the knowledge that we know some of our members are failing the code check, and we may want to consider redesigning them. What we can do then is we can either manually override the cross sections using this approach, where we basically choose a new section for that design group based off of maybe the next largest section in our section list, or we can go to the design input window and we can look at these members as well a little bit closer. So in this scenario, let me just focus in on one design group, and I'm just going to say that I want to select this member right here and all the members that share that design group, which is quite a large number of them. I can actually filter them all here, and you can see it kind of forms this draped shape over these arch trusses. And I want to look at this cross-section design group. So basically these are designed as a single group, meaning that whatever member has the highest utilization in this single group is going to dictate the choice of cross-sections for all the other members in that group. So here I want to click on this design for subset of sections for study. And this allows me to go into this cross-section list and choose which sections might be considered for the design and which ones might be ignored. So I'm just going to call this roof sections just as a generic name, and I want to select this section that has the lowest weight of the available sections. Currently we're using an H428 by 407 by 20/35. And we could consider a variety of other sections in this database list here. We're going to choose the one that works best for us. If we'd like to, we can even set up our own custom user constraints. So we could consider from this list of 96 sections in the wide flange shape catalog, we may want to filter this down to have sections that meet a specific user constraint of ours, whether it's a depth limit or a mass limit or something to that effect. I'm going to just go with all the sections in this list. I'll click OK. And now I'm going to go ahead and run the design. I'm just going to run the design just for this one section group, but we could do it for all of them if we like. And I'm going to say, let's just run the design for these 3 low combinations again. And so what S-Steel has done here is it's returned us to the design results window after the section design has been completed. And what it was doing is it was looking at the cross-sectional sizes, cross-sections that were available, and the demands on each one of those cross-sections, and looking at which members are in that design group to find which section would work for all of those members in that design group. And in this scenario here, it's identified that we've got a new cross-section, and if I just zoom into what appears to be the highest utilization just on the right-hand side here, we can see here that it's chosen a new cross-section which seems to be governed by this member right here. I can right-click and go to Code Details, and I can see here it's showing me the original S-frame section, W428 by 407 by 20/35, and the proposed section is a larger cross-section. And it's telling me that only 2 of the cross-sections that I had in my list are available and admissible that will pass the code check. And it's sorted this based off which one has the lowest weight. I can see the code details for this cross-section, and I can see the utilizations for each one of these applications. In this case here, it seems to be governed by flexure and compression interaction check for both of the, or all 3 of our load combinations. So what we could do now is we could assign this to our model, reanalyze the structure because we have changed the cross sections for the design group that we considered. We'll have a new mass and new stiffness, so we may want to look at the new regime of forces, especially if we change the design section quite a bit. And we can iterate this process automatically for ourselves as well, or we could just update the analysis model and work with that. Now this design operation could have been applied to the entire structure, but for this application I chose to just do it just for the roof elements that I've identified here. We hope you enjoyed this presentation. If you'd like more information about S-FRAME or S-Steel, please check out our YouTube channel, and we also have plenty of training available through the Altair One Learning Management System.